I'm a surveyor and I need a drone. Can you tell me more? Hi, my name is Ross Kenney. I'm the UAS Sales and Support Lead for Navigation Electronics. And that question is one that's often asked of us when we're dealing with a lot of our surveyors and engineering customers. A lot of times people are curious and want to know more about drones. And today we hope to be able to present to you what drones are, how they can be used, the type of data that they can collect, the different types of drones and which is suitable for what projects. And then also we're going to be diving into a flight planning tool a little bit later to show you actually how we can plan our missions, showcase the amount of time that can be saved on certain projects when using a drone versus traditional methods. And then we're going to also take a look at some data as well later on to show you what you can actually gain, what information can be gathered from drone aerial collected data. So with that being said, I'll go ahead and get started. So a little bit about us first. A lot of you here today already do business with or know about NEI, but I would like to give a brief timeline of the company. So it actually was founded in 1988 when it was purchased by Charlie Poche. He was our founder. In 1990 was a big step for the company. That was when we became one of the first 5 Trimble distributors in the United States. In 2000, after the unexpected passing of Charlie Poche, his wife, Miss Barbara, and his 2 children, Kelly and William, took over the business and have been growing it ever since. Over the years, NEI has seen a lot of different changes, especially after Hurricane Katrina and different other times. We've had some significant events over the years. We've got the ability to use drones as part of our toolkit. That was back in 2013. Also, we opened a brand new state-of-the-art facility in Lafayette, Louisiana, right across the street from our older building. This is where we service and repair most of all of the equipment for our customers. You know, moving forward, NEI has seen quite a bit of growth with the drones as part of our business, because surveyors and engineers are starting to realize that this is the next evolution of surveyors, very much similar to the advent of GPS back in the 90s. Drones are presenting opportunities to collect data in new ways and potentially even more data than they could in a traditional sense. So that's what we're going to talk about today, is what these drones can do for you. So to start off with, what is a drone? Otherwise known as a UAV, unmanned aerial vehicle, or a UAS. Sometimes you hear it referred to as that, unmanned aircraft system. So really, all that a drone is, or a UAV, is a device without a human on board that is controlled either autonomously or by computers in the vehicle, or under the remote control of a pilot that's on the ground. The term UAS emphasizes the importance of other elements beyond just the aircraft itself. The UAS will typically consist of the aircraft, the control system such as the ground control station, a data link, so the communication between that ground control station and the drone itself, and then other related and supported equipment, such as your payloads that you can carry to collect the data, and such as different various antennas and things like that. So generally that UAS is the term that kind of describes the entire system. So the first recorded use of drones dates back to 1935, when the British Royal Navy began using the adapted DH-82 Tiger Moth aircraft that they nicknamed the Queen Bees. These were actually real airplanes that were converted to be controlled via radio control for gunnery target practice. Over the years since then, the UAS have really changed dramatically in their size, their scope, and their use. Especially when GPS started to become more popular and the satellites were getting launched all around the globe. In the 1990s, the military began using the satellite communication and GNSS navigation to operate UAS at very long distances. from their controllers. And over the last 20 years, the commercialization of UAS has really broadened the scope beyond just military applications into the civil and the commercial realm. You definitely have seen quite a proliferation of the consumer and the hobbyist type drones off the shelf. And while those may be looked at as toys, what we're going to be talking about today are the tools, like you see here on this table, that a surveyor can add to his toolkit. A surveyor engineer can utilize these tools the same way he uses his GPS receiver, the same way he uses his total station, in the same way he could use a terrestrial scanner. And so we're going to go back into it here just a little bit. I wanted to show you guys a brief video about the history of drones, and also, how it's expanded in its military sense over time. So just a quick short video here.
Remotely piloted aircraft had a very significant learning curve. Early examples were always crashing, so this was a pretty difficult endeavor to make happen. As a result, it took a very long time to have really reliable systems. RPAs go back to really the beginning of the 20th century, and for about the first 30 years, so from about 1900 to 1930, RPAs and guided missiles were really the same thing. During World War I, the British wanted to use an aerial torpedo to fight the Zeppelins. Americans, French, Germans were looking at something that they could use to attack ships or land-based targets. And so rockets were too hard to turn into weapons at that time in terms of putting guidance systems in them. So turning an airplane into a weapon was really what they were trying to do. And then in the 1930s, now that aircraft are flying higher and faster, shooting them down really gets to be a very difficult challenge. So they need realistic targets. And one way to do that is by having a remote controlled aircraft that these gunners could shoot at. In World War II, they kind of go back to the idea of turning full-size airplanes into weapons again. The US is using what they call war-weary bombers. So bombers that had flown so many missions that they weren't safe to fly with humans anymore. They put radio control equipment in it, packed it full of explosives, and they flew them against hardened targets in France and in Holland. There is a continuous back and forth between using a remotely piloted aircraft for a weapon system and then using it for other purposes, including reconnaissance. Now, right on the eve of the Cuban Missile Crisis, they're starting to look at using these for reconnaissance platforms. There's a realization that there's a lot of communist-held territory that would be very dangerous to fly over. There's an awareness that the U-2, for all of its attributes, is not going to be invulnerable for very long because the Soviets were developing surface-to-air missile systems.
Within the past week, unmistakable evidence has established the fact that a series of offensive missile sites is now in preparation on that imprisoned island.
They wanted something they didn't have to put a human pilot at risk, a pilot that could be captured. And so they started using these target drones, building them out, putting bigger wings on them, putting autopilots on them, making them a lot more sophisticated, able to carry cameras. And it's really not until the mid-1990s and the birth of the Predator that things really changed. One of the problems that they realized early on was that it was very easy for the Predator to get into a position where a mountain might block the line of sight to the control aircraft or the ground station. And so there was a big push to put satellite data links into it. In 1999, there was another problem that was realized, that it was great if a Predator could spot a tank column in the field, but then if you're going to talk an attack aircraft onto it, like an A-10, it didn't work very well. They realized, let's just put the weapons actually on the Predator. In early 2001, this aircraft was mounted with the AGM-114 Hellfire missile, a laser-guided weapon system, and that gave it an attack capability. This was really kind of a milestone, and not only was it used to develop that new method of warfare that has really become dominant over the last 17 years, but it also was really the first to truly demonstrate that capability in the field. I think over the next century we are going to see a move to more autonomy, but it is a huge leap. It's one that is very, very difficult. It's going to require some very significant advances in artificial intelligence, but we're not really quite there yet. So we're talking about something that still has a pilot, but the pilot's not in the aircraft.
So that's a little bit about the history of drones and unmanned aircraft systems and where they got their start in the military applications. But let's talk a little bit more about what a UAS is to you in the audience. So an unmanned aircraft system is really just a tool or a mechanism to gather data from the air, oftentimes more quickly and potentially more safely than can be done on the ground. A UAS is simply the means to carry a sensor airborne and collect data. UAS present opportunities to improve upon the efficiency of data collection and the quality of that data that you can collect in the field. Not only the quality, but also the quantity and the amount of data that you can collect from a drone in a shorter period of time. UAS can often operate and gather data in areas previously too dangerous for humans to operate or where manned aircraft cannot simply get to. UAS in major industries are tools and not the toys that you see online or some of your grandkids that might have drones that you see flying around. These are really tools that can be used to collect survey-grade accurate data. So let's talk a little bit about how this begins. So we deal with a lot of different customers at NEI that come to us for a variety of reasons when they're interested in learning about drones. 5 of the common themes that we see is, number one, it's project driven. The customer is aware that a particular project would be better suited to be flown with a drone than to be surveyed in a traditional sense. That's a very common theme that we see very often that usually starts the conversation. Another one is if any of your clients request a drone be used for a particular project, either because of a safety reason or because of a marketing reason. We've seen that as well. Sometimes clients will request it just to be able to promote the fact that they're using an unmanned aircraft system and it's less of an invasive type of a way of collecting data. Sometimes it's just curiosity. Some people have heard of their colleagues that are using drones for various things. Maybe they saw something online or learned about it in one of the geospatial magazines. So sometimes they come to us just with curiosity to learn about what drones can do for their business. Some people are just looking to expand and diversify their business. They believe that the drones, like many others, are the next step in the evolution of surveying, and they want to be a part of that, and they want to expand and diversify their business away from just the operations that they're doing currently. And then another one is very common we see toward the end of the year is tax write-offs. Section 179 allows them to write off a significant portion of the cost of these systems like they do for many of their other purchases. So we see that as a driving force in how the conversation begins surrounding drones. So then, once someone comes to the table and is interested in learning more, how does it then develop from there? So really, it starts with us analyzing and getting a good understanding of the types of projects and applications that a client has, and then figuring out what the right solution from an aerial standpoint, if an aerial drone is the right solution at all. So that usually will then lead to a meeting with the customer where we would discuss the current projects that they're working on and also really dive into a specific example using a project Google Earth KML where they can share the exact location of the job, describe to us the deliverables that they're looking to create for that job, and then from there, that's when we determine what the right sensor is for the drone. So if we could look at the drone real quick, so the aircraft itself is all about carrying the sensor. The drone sensor is where all the data is collected. This is the most important thing. And a lot of people get caught up in the coolness, if you will, of the drone flying and everything. But really, that's just to get to the data. And the data is the most important aspect of the whole operation. So determining what that right sensor is, depending on the type of deliverables you're trying to create for your customer, is very important from the get-go. So we like to analyze the project site and then determine what the right sensor is. And then ultimately, we would then be able to bring that project KML into a flight planning tool that we'll talk about here a little bit later, and then start to build our mission plan around that. So we'll start to plan how high do we need to fly? Are there any obstructions in the area? We can also look at and analyze what the airspace looks like in that particular area. Are we going to need to use another application to be able to file our flight plan with the FAA? We'll talk about that in a little bit as well. And then finally, we like to be able to compare the time that it takes to complete that example project with a drone to how long it would have taken a traditional 3 or 4 man survey crew to go out and survey it. And then what is that data going to look like in the end? You know, the data may be collected by the field crew at a 25-foot grid or a 50-foot grid. And if we're talking about a LiDAR or a photogrammetry derived point cloud, you could be talking about 25 plus million points on that same project site. So that makes a big difference in terms of the amount of data you collect, because sometimes you pick up things you didn't think you needed, and that could prevent or eliminate the need to have to go back to the site and resurvey something when your customer comes to you and says, hey, I actually need you to go and gather some information in this other area that wasn't the primary focus of the first trip out to the job site. So a drone really can expand the ability of your field crews to really force multiply their efforts in the amount of data they can collect, and can save you that time and money for having to redeploy to a site because you've collected so much of the data. So that's a little bit of how it develops. Then let's talk a little bit more about, let's dive into the drone and the payload a little bit more. So what we have on display here is a Microdrones MD4-1000. At NEI, we are a distributor, obviously, for Trimble survey equipment, which many of you already know. But in addition to that, on the quadcopter side, we are a Microdrones distributor. And then also on the Fixedwing side, we are a distributor for SenseFly. So let's distinguish those two things a little bit here in a second. Also, commonly asked question is LiDAR or photogrammetry? If you're familiar with the two, we're going to dive into them a little bit further, but not every project is suitable for a LiDAR-based solution or a photogrammetry-based solution. So we'll talk about that here in a little bit. Do I need a base station to go along with my drone? The answer to that question is yes. So whether you're flying to collect photo data, or if you're flying to collect LiDAR data, or any other type of data, you usually need to geo-reference that in some way. And so basically the way that would work is while you're flying, you're going to have a GPS base station set up on site, usually on a known control point. That base station would be logging static data at a 1-second interval rate, beginning 15 minutes before the first flight when you take off, and ending that session 15 minutes after you've completed your mission. If you don't have a known point on that location, then just a minimum of a 2-hour session needs to be logged, also encompassing 15 minutes before your first flight and 15 minutes after your last flight. And then RTK or PPK is another common question. And so we'll talk about that here in a little bit. I want to move on to the next slide so you guys can see the two different drones. So this is kind of what I was referring to a little bit ago. So for those of you who are familiar, on the left side of your screen is this drone. It's a quadcopter. So this is just a rotary platform, the ability to take off and land the system vertically. And then on the right side of your screen is the fixed-wing drone. This is a SenseFly EBX. Both of these drone manufacturers have been around for more than 10 years, and in their respective markets, a rotary system and a fixed-wing system, they're some of the most prevalent drones on the market today. And this is generally speaking because of the fact that they're both fully integrated aircraft. So we'll talk about the integration of everything a little bit later, but let's talk about what the difference is and the importance of why a quadcopter or a fixed wing may be more appropriate in certain situations. So quadcopters generally have a greater payload capacity than your fixed wing varieties. And when I refer to payload, I'm talking about whatever sensor is being carried on the drone. That's what we're talking about with payloads. These sensors here can range from LiDAR, photogrammetry, methane detection, inspection type cameras. So whenever I refer to payload, I'm just referring to the sensor that's being carried on the drone. So in addition to having a greater payload capacity, you also have the ability to take off and land in confined spaces because it is a rotary aircraft. Additionally, from an inspection standpoint, a rotary system or a quadcopter allows you to hover in place and kind of focus on one single point of interest. And then also it does allow for manual control. So as you see here, we also have the RC, or the remote control. So the RC gives you the ability to take off and land the drone manually, but still allows you, through the connectivity of the tablet, to upload the mission plan or the flight plan that you've prepared to the drone and be able to see on your screen where the drone is located. So you have the flexibility in a rotary platform like this one to be able to take over control of the drone at any time, but also have it fly on its own in an autonomous way. You can also call that like an autopilot. So unlike the quadcopter systems, the fixed-wing drones generally have a longer flight time. They're generally lighter weight systems, so they don't have necessarily the same carrying capacity as these drones, but you still have the ability to carry a camera of 20 to 24 megapixels, which is great for photogrammetry. These platforms are best suited for flying larger areas, larger style projects, very popular in agriculture and just really larger sites of greater than 100 plus acres. Those types of drones, the fixed wing varieties, are best suited for those applications. Unlike a vertical takeoff, in some cases you do have VTOL or vertical takeoff and land options on these fixed wings, but in the example of the SenseFly, the EBX is a hand launch system. So essentially it's a 3-shake motion. It motors on, and then the drone, you just launch it with your hands. And then instead of being controlled by an RC like you see here, it's actually controlled through a radio link that connects to a laptop, which is your base station. You may remember earlier that that's one part of the whole setup is a ground control station, or sometimes called the base station. That is going to be what communicates the commands from your flight control software to the drone that's in the air. So in the case of the SenseFly EBX, you do so from the laptop. You can give it commands, but you cannot actually take over control with an RC. You can tell it to fly to certain locations, you can tell it to change its height, and then you can assign it to certain mission blocks that you have prepared. So that's a little bit about the difference between the two. I wanted to talk a little bit more about the difference between an RTK and a PPK setup, and why the preferred method amongst us and our customers is usually the PPK variety. So obviously RTK stands for real-time kinematic, and essentially what you're doing is you're marrying the base station file with the data that's being collected by the drone. So in an RTK setup, this would be done through some type of a connection between your receiver and the ground control station. So as an example, when you talking about the fixed wing drone that's being operated from a computer, you would simply have a cable that would run from your receiver to the same laptop that's being used to pilot the drone. This would then allow, as long as it's being logged in a 1-second rate, it will allow for, as those photos are being taken by the drone, those corrections are being sent automatically to the drone's camera. Therefore, when the camera snaps its photo, each photo is also getting geotagged at the same time with the X, Y, Z, the lat, long, and height of each one of those photos that's being taken. Now, the reason we don't prefer that method is because, number one, you don't really need the geolocation data live while you're flying. The drone has its own onboard GPS to give it its positional accuracy, which is why we prefer the post-process kinematic or the PPK workflow, because you have the ability to do all of what these corrections are doing in flight. You can do so after the fact. And from a field crew standpoint, it also makes it easier for those guys that are out in the field collecting the data, because now, especially if they're going to be flying all day long and they have a lot of data to collect, they may have several locations that they need to move to, in which case every time they move, they would have to break down their base station, move to another location, and then set up their base again. So this actually, following a PPK workflow, allows your field crew to just set your base up on a known point at the beginning of the day. You can actually use the base station to perform post-process kinematic data collection, but having an external battery providing it ancillary power is going to allow that base station to log its static data all day long. So essentially your crew can set it, forget it, and then move on to focusing on collecting data with the drone. It does not have to be tied to your base station. Those two systems can operate independently of one another. So that's why at NEI and with most of our customers, they like to follow the PPK workflow. Let's process and geotag all of our photos or georeference all of our LiDAR data after the flights have been completed back in the office. Another reason for that is there could be latency in the middle of your flight where you may have a photo or two that doesn't get geotagged amongst the hundreds of photos that you've taken. In those cases, you've got to go back and follow the post-process kinematic workflow anyway. So that's why we always prefer to just follow that PPK workflow. So now that we've talked a little bit about the differences between the two different drone platforms, both fixed wing and quadcopter, we've also talked a little bit about the RTK and the PPK workflows. Let's talk a little bit more now about the different sensor applications, and specifically the two most commonly asked of us is, what can we do with a LiDAR sensor, and when is a photogrammetry or a photo-based setup most appropriate? So let's dive into that a little bit, and let's talk about LiDAR first. So a lot of people may not even know what LiDAR is. So LiDAR actually stands for light detection and ranging. It's essentially a laser scanner that's underneath the drone that will emit several pulses of laser at a certain swath and a certain width to be able to collect data on every object that's on the ground, including the ability to be able to penetrate through tree canopies. So the whole setup here, this diagram that's on display, kind of talks about all the different components that go into collecting LiDAR data. So obviously, like we talked about, you have your GPS base station that's on the ground. That's going to be set up, just like we talked about, on a known point encompassing 15 minutes before your first flight, 15 minutes after your final flight. If a known point isn't available, then a minimum of a 2-hour session needs to be logged 15 minutes before and 15 minutes after the flight duration. So this is going to be important for georeferencing our data. In flight, however, we onboard either the aircraft or the sensor is what we call the IMU, so the inertial measurement unit. In the case of the system you see on on the table here. Again, this is the Micro Drones MD4 1000, and Applanix, which is owned by Trimble, produces the APX15 IMU, or that inertial measurement unit, that is on the sensor itself. So this inertial measurement unit is all about calculating the orientation of your sensor, or more specifically, the pitch, yaw, and roll at each moment that the scanner is actually collecting data. So even before we post-process our data and georeference everything, the inertial measurement unit already gets it into the right orientation. So you can almost think of this as in-flight georeferencing, so to speak. And then you have the laser scanner, which, as I said, it's going to emit infrared pulses, and every scanner is different. The scanner that's on this drone in particular is a 3-return laser scanner. The rule of thumb is the more returns your LiDAR sensor has, generally the better ability it's going to have to be able to get through vegetation and penetration to get points down to the ground. And that really leads me to my next point, as when customers are asking us, and we're in that discussion about the types of projects and the types of deliverables they're looking to create, oftentimes it's topographic surveys in many cases that, as a surveyor, many of you know, historically, the only way to survey in a wooded area is to, oftentimes you have to cut line through those woods. And then you may only get a point every 25 or a point every 50 feet. When you're talking about a LiDAR-based aerial application, now your field crew really doesn't even need to go into the woods and cut line. You can actually plan an automatic mission with the drone, and it can scan everything beneath the trees down to the ground. And so the rule of thumb there is the more returns the laser scanner you're operating has, the better its ability to penetrate through the tree canopy. It's all about the number of returns and the amount of points per second that the sensor can emit. And so that will equate to sometimes in the range of 60 to upwards of 120 to 150 points per square meter down on the ground versus 1 point every 25 or 50 feet. So like we talked about a little bit earlier, the quality of the data you collect also goes right hand in hand with the total quantity of data you can collect versus a traditional surveying method that a drone is able to do instead. So if you can imagine a 60-acre topographic survey in a wooded area, we recently did a demo for one of our customers where they told us it was going to be at least a minimum of 2 to 3 weeks for them to survey this area. We wanted to demonstrate to them that the drone could come in a matter of a couple of hours. We had everything set up. It was about 9 o'clock in the morning, and we were off the site, base station and drone, everything broken down by 11:30. And then from there, it's about, like we talked about earlier, georeferencing all that data to the base station file, and then classifying that data, which we're going to talk about a little bit later in Trimble Business Center. Okay, so that's a little bit more about LiDAR. Let's talk about scenarios where, let's talk about some of the attributes that you should look for in a UAV-based LiDAR solution. So some of you in the audience may already use terrestrial scanners for your businesses. So you can think of this as just a terrestrial scanner in the air. And so what are some of the attributes should I look for in a UAV-based LiDAR solution? The first thing that we like to point out, and we think is one of the most important things, is having a fully integrated workflow. And what I mean by that is we have a lot of moving parts that are going on in this operation here. And you've got the drone, you've got the sensor, you've got the software that is on the tablet here that pilots the drone. You have the software after the fact that will post-process all your data. So this is a lot of different moving parts, and having all of them work together cohesively in an integrated way really is going to make your life as a surveyor a whole lot easier. It turns this into a useful data collection tool and less of a science project that you got to figure out. The other reason why a fully integrated solution is very important is from a support standpoint. As most of you know, we here at NEI, we really pride ourselves in the support that we provide to our customers. We understand that downtime is no good for you and it's no good for us. So when problems do arise, having this as a fully integrated workflow means you have one point of support to go to, and that is the distributor who provided you the drone. If you're talking about a different setup, which we would call a non-integrated or a modular setup, you may have one vendor that sells you the drone. You have another vendor that would sell you the payload or the sensor. Then you have another vendor that would sell you the software that's needed to pilot the aircraft. And then you may have a fourth vendor that provides the software to post-process your data and do everything after the flight is completed. So that means when a problem could arise, a scenario could be foreseen that you may think the problem is because of the drone. You go to the drone vendor and they tell you, no, it's not the drone, it's the software. And then the software manufacturer tells you, no, it's actually the sensor. And so then you could end up with a lot of finger pointing, and it could be difficult to actually get to the crux of your issue. When you have a fully integrated setup, that's not the case. It's very easy to identify those problems because you have one point of contact to deal with instead of potentially 3 or 4. So that's why we have that first on our list, a fully integrated workflow. Secondly, kind of goes back to what we talked about just on the previous slide. Having a high precision inertial navigation system, otherwise known as an IMU, that we talked about a little earlier, paired with your sensor is very key. Having a great LiDAR sensor is only half the battle. You got to have that high precision IMU where as the scanner is collecting its data, it's also taking into account the orientation of the drone. The drone is up at 50, 60 meters in the air, and there's a lot of different things going on up there. The wind is moving it around and everything. And so having the IMU is going to really make sure that the data you're collecting is precise, it's clean, it doesn't have a lot of noise. So that IMU is a very important component to all of this. We already talked about it as well a little bit, but I'll drive the point home further. A LiDAR sensor with multiple returns, the more returns, the better. Because the rule of thumb, as most people are using this LiDAR to collect data in densely vegetated environments, the rule of thumb is lower and slower flights will give your laser sensor the better ability to penetrate those tree canopies down to the ground to get your ground shots. So that's a very important thing. The more returns that you have, the better it's going to have the ability to do that, and you don't have to slow down and lower your altitudes very significantly in those cases. So like I said, the rule of thumb is lower and slower when you need to penetrate, higher and faster whenever you are flying over an open area. Let's say the site has already been cleared and you're just trying to get elevation information on a hard surface or a ground surface. In that case, you really don't have anything to penetrate, so therefore you can fly to the maximum height the sensor can collect data at and the maximum speed, because you certainly won't have the need for super high density point cloud in that situation. Another thing we like to talk about is the system that you're looking to use LiDAR for in a UAV-based LiDAR solution. You really want to look for something that has low maintenance and the ability to grow with your organization. So number one, let's talk about the aircraft itself. So really you want to find an aircraft, number one, that's going to give you the ability to get a good return on your investment. And by this I mean a lot of drones, especially the technology, and I know many of you probably have had this thought yourself, is that I don't want to get into these drones because it's just too much going on too quickly. I don't know one day to the next with the technology constantly changing. If I buy this drone today, it's going to be obsolete by the next year and I haven't even made my money back on it. That's a common theme that we hear from people. And one of the things I want to point out is some drones on the market, like many of the consumer drones you see, there's a new one that comes out every year. What I can say about this particular aircraft is that the overall airframe design has remained the same for 15 years. There have been incremental improvements in terms of how it flies on the drone's firmware, software improvements, but generally speaking, those clients that have been operating these systems for a period of time have more than enough paid for their investment plus a very nice amount of profit because they've been able to keep the same airframe, and the ability to grow their organization is tied hand in hand with the fact that since the drone is a fully integrated setup and there are so many payloads that can be put onto this drone, you don't have to buy a brand new drone each time you want to do something new or collect a different type of data. So finding a drone that is fully integrated with the ability to plug and play multiple sensors, as your customers come to you with new requests for different types of data collection, you will already have the platform that will enable you to add a different sensor over time. So that'll give you the ability to expand your business into new sectors as needed. And then lastly, very importantly also, is a strong training and support network. Unlike a brand new GPS receiver, which you and your field crews are very used to operating, you've probably been operating for more than 10 years. In many cases, this may be the first time you've ever operated a drone. So having on the outset, a good training, a week of training to actually go through all the different types of scenarios that you may encounter is very crucial to building your confidence that you can deploy this instrument and you can make money as a surveyor. And then beyond the training, making sure that whoever you're purchasing your drone from isn't just going to shake your hand and say, on your way and best of luck to you. You got to have the support after the fact. Generally speaking, and to be quite honest, it is somewhat of a learning curve to develop the skills necessary to fly your drones. But the people, our clients that are using these drones, range from sole proprietors. We've got some clients that are much older, in their 50s and 60s, that are able to operate this system themselves. And then we also have larger companies, and then everyone in between that are using these systems. And that is because after the sale and after the purchase, the support that we're going to provide you on the system is going to be there. And so that's really the fifth thing that we would point to as what you should look for in a UAV-based LiDAR. So now that we've talked a little bit about the LiDAR-based UAV solution, that's one aspect of things. Again, really working in vegetated environments, canopied environments, that's where a LiDAR setup is really ideally suited. Another thing I want to point out before I jump into photogrammetry is just the data itself. So I think one of the things that we have people come to us with is a common misconception that LiDAR data is inherently very heavy. It's very cumbersome. And this may be due to the fact that the LiDAR data you've worked with in the past has been very large data sets, perhaps statewide LiDAR surveys and things of that nature. But generally speaking, LiDAR data is a lot less cumbersome than photo data. Photo data from a camera is generally a lot heavier and much more compute resource intensive on the back end when you come to process your data. But in some cases, photogrammetry, and what we'll talk about here in just a second, is a requirement as part of your deliverable. The customer may want updated aerial imagery of a high resolution geo-referenced of the project site. So you may be able to use LiDAR in certain situations, and maybe you have to collect photo data as well as part of your deliverable. So let's talk a little bit about what photogrammetry is. And the difference between LiDAR-based collection and photogrammetry collection. So photogrammetry, in a simple way, is simply a drone carrying a camera that also does have an inertial measurement unit, just like the LiDAR, in order to be able to calculate the pitch, yaw, and the roll of the camera as each photo is being taken. So when we plan our missions, there are several factors when we're collecting data with a camera-based setup. So number one, we're going to want to fly as high as we can, and we'll talk about the regulations and what that allows for here in a little while. But we want to also input what is the overlap between the photos as our drone is flying down the line. So it's going to trigger the camera at a regular interval, and we can dictate how much overlap we want between the photos on the line that the drone is flying. They call that front overlap. Okay? So we also have to determine how much overlap do we need on the lines that are adjacent to it. So the photos that are on adjacent lines, we need to indicate what the amount of overlap is there. So essentially what photogrammetry is going to do, using structure from motion software, that's another term for photogrammetry, is you're going to use software that, following your flight, you're going to geotag your photos, meaning put the information of the X, Y, Z, lat, long, and height into the actual photos themselves. They call that the EXIF data. And then you're going to basically stitch all of those images together, what they call in the tie point extraction step. So what you're ultimately trying to do is to get to one, what we call orthomosaic, of, and you can also refer to it as just an aerial image that is geo-referenced, that you can use as your background map for your deliverables for your customers. But also similarly to LiDAR, you can derive a photo-based point cloud. Instead of it being gathered from a laser, it's actually gathered from the camera and the stitching of all those images together. Now, the differences between photogrammetry and LiDAR is photogrammetry is a single return. So if you're trying to collect aerial imagery over trees or vegetation, you're just going to get the tops of those trees. So you're not really going to be able to derive elevation information on the ground with a photo-based system when you're flying in a canopied environment. So that's why we want to really identify the project mix for our customers and figuring out what's the right solution. But as I said earlier, in some cases, you may need to use LiDAR and photogrammetry as part of your client's deliverables. Where we find photogrammetry is most useful is on sites that have already been cleared, potentially construction sites for progress reporting and updating. You can also use it for stockpile volumetrics, so being able to calculate those volumes, photogrammetry, so long as the stockpile is fully exposed, that camera is going to be able to pick all of that up in the process of flying your mission. So really you can think of the difference between the two as the type of application. If you're talking about heavy vegetation, tree canopies, that's when a LiDAR setup is more appropriate. If you're talking about just getting updated aerial imagery that's also geo-referenced, and you're not as concerned with the elevation change, then it's okay to do so over a tree canopy environment. It's just important to remember that overlap we talked about a little bit earlier, flying higher and flying with greater overlap is going to give your software the best opportunity to find tie points between the adjacent images. Okay, so this is an important thing because if you can imagine, the higher the drone is up in the air, the greater the footprint on the ground each photo will be. So therefore, when the photos are looking for common features to tie to on the next photo, the more area coverage that it has, the better the ability that software is going to have to be able to automatically find those tie points. So that is generally, at a high level, what photogrammetry is compared to LiDAR. Let's talk a little bit about the different aspects of photogrammetry here. So on the screen here, you have 3 different types of scenarios. If you'll notice, on this particular setup, you have these red lines here. Those I would refer to as our flight lines. So as we're flying down the line, the front overlap, in this case 80%, each photo is going to overlap the next by 80%. What we're talking about here is an aerial triangulation setup where your drone and the camera on your drone does not have the ability to be post-processed to a base station that was logging static, and does not have an IMU, an inertial measurement unit, to be able to calculate the pitch, yaw, and the roll of your drone. So therefore, what this requires you to do in order to be able to collect survey grade accurate data, you've got to be able to not only fly with a great amount of overlap, which would be 80% on the photos being taken as you progress down this line, but also 80% on the photo on the adjacent line. So what you end up with is a lot of photos. But also, in order to georeference it, because you can't use a base station in an aerial triangulation setup, the triangles that you see represented on your screen are what are referred to as ground control points or ground control targets. So think of this as a 1 foot by 1 foot or a 2 foot by 2 foot target that is visible from the camera, that you would actually use a GPS base station or a rover tied to a network, and you're going to go in and shoot a point directly on the center of that target. Usually the target will have an X or some type of a cross that you can hone in exactly on that point. So as your field crew in an aerial triangulation setup, they're going to need to not only collect the image data, but they're also going to need to collect the GPS points on each one of the targets. Now they've got to go out and put the targets down before the flight, and then after the flight is complete, they've got to go out and recollect all of those targets. So in this setup, ground control points are always needed, generally 10 to 12 ground control points about per flight that you conduct. Okay? So this is when you're talking about, again, a setup that isn't available to be run in an RTK or a PPK workflow, and it doesn't have the direct georeference option as well. Let's talk about this middle option here. So a PPK or a GNSS assisted aerial triangulation setup. So again, this is kind of what we were talking about earlier, where your base station is set up on a known point logging static data. However, your camera in this case does not have an IMU. Okay, so you've got to then continue to fly with the same amount of overlap, 80% front lap, 80% side lap, but you can greatly reduce the amount of ground control targets needed to be able to georeference everything together. So in this case, with a GNSS assisted aerial triangulation setup, think of it like a dice, a 5-pointed dice, where you're going to want a ground control target somewhere generally in the corner, not directly on the edge, but somewhere toward, in the corner, and then you're going to want to have one in each corner and somewhere in the center. This way, you're going to still be able to get that survey grade accurate data that you're looking for, along with the base station that's logging static. You're going to use that. So let's talk about a little bit about how that looks on the back end. So essentially, when you're talking about your post-processing software, like for example Pix4D, before you actually set it to run, you're going to go into each photo where the targets are visible, and you're going to indicate to that photo, you're going to zoom in on the target all the way down to the cross where you shot that point in, and you're going to indicate to the software and tell it point number 1 corresponds with this pixel on this image. you're going to actually physically go in with your mouse on your screen. You're going to click on that center point. Okay, and you're going to do so for each image in which these targets appear. So flying with 80% front and side lap, you may have 8 to 12 images per target that it will appear in. So then you go ahead and you'll select that. And so it's actually going to tighten down your final product a little bit better. Now, lastly, the direct georeference, we refer to it as DG, allows you to, because the IMU is active, you're going to be able to lower the amount of overlap you have between your photos on the lines, each of the individual lines and the adjacent flight lines. And you can also reduce the amount of targets that you have as well. Now, as a surveying best practice, what we always recommend, depending on the environment, is that you still have at least one target to shoot in and tie into, and then you also have one or two check shots that you can refer to for your elevation checks as well. That's always a surveying best practice, in addition to having that base station logging the static data as your drone flies. So what you can do here is greatly reduce the amount of time on the back end when you're actually processing your data, because you're going to have fewer photos to process. And as we talked about earlier, photos are generally the heavier of data that you can collect than LiDAR. So anything that you can do to reduce those photos that you have to stitch together means you're going to be reducing the amount of time to get to your final deliverable for your customers. So now that we've talked about the various types of ways you can collect photogrammetric data, let's look a little bit more into what types of applications would be suitable for this and what kind of deliverables can you create for your customers. So drone-based imagery and even LiDAR can bring you much greater insights on your projects. So high accuracy photogrammetry can allow for feature extraction and classification. So you can actually pull from your data sets, your point clouds, you can actually do a lot of that line work you would have done in AutoCAD and Civil 3D. You can actually do that line work in drawings in Trimble Business Center right off of the point cloud that was derived, because you'll be able to see all of those features, like your fence lines, like your curbs, like your sidewalks and your edge of pavement and your building perimeters. All of those things you can now draw in from the data your field crew has collected, and they don't have to necessarily go in and physically shoot all of these points in order for you to be able to do your line work. Obviously you can create, we talked about earlier, your orthomosaics and your point clouds. This is an example of a 3D point cloud that was derived from a photogrammetry based setup. Here's a zoomed in location of one of the on this site. So you can produce that. You can produce digital elevation and terrain models that can then lead to the ability to build surface models and contour maps. We talked about it also a little bit earlier, the ability to fly your stockpiles for volumetric calculations. This can be done from either a photo-based setup or a LiDAR setup. And then importantly, in many cases, you may have the requirement to continually update a job site. And these aerial images give you the ability to document that change over time, especially if it's going to be a long-term project for you. You now have the ability to not only see a snapshot at that time, but then refer back to that data set as the project progresses for QA/QC purposes. So we talked about it a little bit about how we operate the drone. Let's talk about the regulatory side of things. So some of you who are already flying may be aware of this, and some of you who aren't flying may not be. But essentially what you need, and all you need, is to pass the FAA's aeronautical exam and become a licensed Part 107 pilot. In 2016, the FAA issued new rules for small unmanned aircraft. These rules were implemented to ensure the safe integration of unmanned aircraft systems into the national airspace. The FAA set forth these guidelines for both recreational and commercial UAS pilots to abide by. The only requirement is that the pilots pass the aeronautical exam to ensure that the pilots are aware of the rules that govern the skies. Some of those rules are: the total weight of the system must be less than 55 pounds. The drone must be within the operators or the remote pilot in command. It must be within their visual line of sight at all times. The drone may not be operated over people that are not directly involved in the operation. The drone or UAS may only be operated during daylight hours, 30 minutes before sunrise and 30 minutes after the official sunset. UAS must yield the right-of-way to other manned aircraft. The maximum altitude that UAS may operate in Class G airspace is 400 feet. The maximum ground speed must not exceed 100 miles per hour. And the UAS may not be operated within controlled airspace or near airports without prior authorization. So, pilots that are looking to do more advanced operations or outside of what the current rules and regulations allow for are able to go through a waiver process through the FAA to be able to alleviate specific parts of the rule, as long as safe operation can be verified by the FAA. The majority of waivers that have been issued beyond what the regulations currently allow have been for operation at night and for flights in controlled airspaces. So we would refer to that as an airspace waiver. Very few waivers, however, have been granted for beyond visual line of sight flights and flights over people not involved in the operation. There have been a few, but not very many. The FAA is actively working towards really opening up the drone marketplace as the technology becomes better and safer to allow for the beyond visual line of sight flights and the flights over people. So let's talk a little bit about that, because the FAA realized that there are areas oftentimes that surveyors and other drone pilots need to operate in and collect data that may be within the controlled airspace of an airport. So they announced a couple of years ago their LANCE system. And LANCE stands for Low Altitude Authorization and Notification Capability. And essentially what it is it provides drone pilots with near instant approvals for access to controlled airspace at or below 400 feet. So essentially, as a pilot, it is your responsibility to know the airspace you're going to be flying in before you go and conduct that operation. And the quickest way, and the way that I like to do it, is when I'm going to go fly a mission, I'm going to use a free application that's available on iOS and Android. It's called AirMap. AirMap allows you to visually put a point on the map and see if there are any if there's any restrictions for that particular airspace. Now, the LANCE system is signing airports up around the country to be able to provide that automatic authorization. It's enabling the airports and the control towers visibility to the fact that there would be a drone operating in that area, and it allows for drone pilots to ensure the safety of their operation, because the other pilots in the area will be notified that there's a mission going on. So LANCE is continually adding more airports around the country to this system, and it's very simple to use. Again, it's all on that AirMap app. You can just simply file the notification, and within about 3 minutes you can get approved to fly that mission. You can do so days in advance, or you can even do just right before you start to fly. It's always good, though, to do a little bit of reconnaissance ahead of time to know what you may be facing, because not in all areas is LANCE available, and sometimes you have to go through the older waiver approval process with the FAA, which requires you to submit through an online portal the parameters of the mission you plan on flying. Air traffic controllers, again, are given this visibility when the drones are operating. So it's really all about communicating with those that need to know what kind of an operation you're going to be conducting in that area, so we can ensure the safety of other aircrafts in the national airspace. Let's talk about another thing that is commonly asked of us, insurance. And that's a great question that many customers ask us. So insurance with drones, first and foremost, it's important to remember to ensure that your policy that you get for your drone will cover not only the liability in case of a crash and what that may cause damage to other people or property. You also need to make sure that you've gotten hull coverage as part of your policy as well. Hull coverage refers to everything on the drone and the drone that it's carrying in the case of a crash. So that's the most important thing for the policy. Also important to note that your general liability policy that you may have for your company usually does not extend to cover the drone aircraft. It's usually going to be a separate, unique policy. A great thing is a lot of insurance carriers now that drones are becoming more prolific, and they're also becoming a lot safer, and they just have more data to go off of. These insurance carriers are able to offer this coverage, and the premiums are becoming lower and lower because the drones are proving to be very safe to operate, especially in comparison to a manned aircraft to collect similar data. But aside from having a dedicated policy to a drone, if all you were looking to get was on-demand liability, there is another application that you can use. It's called Verifly. Verifly will provide you on-demand drone coverage at a specific location that you indicate the time and the duration and the amount of coverage that you would like for that operation. I think it's up to $10 million in general liability. So you can look at that as something that you can add additional coverage to if you already have a policy for your drone, and let's say your client requires a higher limit of coverage than just your current policy allows for, then you can get this on-demand insurance on your phone that is for your specific location for the duration of time that you plan to conduct your mission. Again, that app is called Verifly, and you can pay for it with a credit card whenever you actually indicate in the application what your mission is going to be. So here's another big question that a lot of our customers ask us is, I'm getting into these drones, I'm not sure how I should charge for this thing. How am I going to make my money back? And that's a great question. And the answer is really unique to your specific company as to the best ways you can monetize this investment. So several schools of thought for how you can charge for your operation. The one that I mostly recommend is look at a project that you're going to go do with a drone as you would in a traditional sense. What would it require and cost you, and what would you need to charge your customer to deploy a 3 or 4 man crew to go and complete that in a traditional sense? You would do so, over a 2 or 3 week period. This, if you're going to be bidding a turnkey price for your customer, this could be the most important way to charge for this drone, which is to say that a lot of our customers are concerned that if a drone can come in here and get this job done in 2 hours, well, there goes 2 to 3 weeks of a 3 or 4 man crew that I could have charged for. Whereas if you're going to bid the same rate or a slightly lower rate and pass some of those savings on to your customer that you would have charged for a 2 to 3 week data collection for a 3 or 4 man crew, Now your profit margin is going to be so much greater because it's still the same turnkey price. You're collecting a higher quality level of data in a shorter amount of time, and you're also going to get so much more data that may prevent the need to have to go back out to that site and resurvey it again or collect other data that your client may subsequently request after the first deliverable is sent. So that's generally like what I like to recommend is a turnkey fixed price, very similar to what you would normally charge for your normal field crew data collection, boots on the ground. The drone, again, will enable you to complete the job faster, thereby increasing your profit margins. Another thing that I have seen is that customers may charge, if they're going to be charging by a day rate, they may add a technology fee for their individual crews. This way, a technology fee is going to enable them to track the revenue that their drone is able to generate. So that technology fee would be applied for if the drone has to go up for one flight or if it's got to be flying all day, in addition to whatever your normal crew rate would be for that day. And then the other thing I've seen is a per mile and a per acreage charge. So that's another thing. If you're going to be dealing with corridor missions, let's say in a power line setup, a lot of the times customers can use this LiDAR-based solution to fly for power companies to do asset inventories and things of that nature. In that case, it may be better suited for you to charge at a per mile rate. Again, this can be tied to what your normal 3 to 4 man crew day rate would have been, and you can just convert that into a per mileage charge. Generally speaking, with a quadcopter drone with a LiDAR-based solution, you can expect to cover about 10 to 15 miles in a day, depending on the conditions of the project and your ability to quickly move on down the line. So that's just a general idea there. And the other thing is sometimes it's a per acreage estimate. If it's more of like a topographic setup instead of a linear corridor mission, then perhaps a per acreage charge is the best way to monetize the system. But those are generally 3 ways that we've seen in the marketplace. So now that we've talked a little bit about how do we charge and the different types of drone applications and insurance requirements, let's talk about a little something fun. Let's talk about the future of drones. Let's talk about what's in development. And so I've got another short little video here I'd like to show you about what NASA is working on with unmanned aerial vehicles. So now that we've talked a little bit about the drones and the different aspects of what you can do with them, the different sensors and insurance requirements, regulatory requirements, let's talk about the different industries that you can really use drones for, and what industries they're really making a difference in. Photography is probably the number one. The consumer type drones that can be bought off the shelf and you don't really need to georeference with can be used in a real estate environment to be able to showcase a property, can be used to host record an event like a wedding or some things like that. So photography is definitely one of the biggest things that drones can be used for. Search and rescue operations using thermal cameras. Wildlife management to be able to do inventories of livestock and cattle and things of that nature. Agriculture using multispectral cameras to be able to hone in on areas where early onset of disease is maybe occurring, or maybe improper drainage is causing the crops to not grow to their fullest potential. So multispectral sensor can enable you early insights into problematic areas. Also, if you'll notice in this picture here, there's even now drones that have the ability to carry pesticide and fertilizer and different things, to where you can actually apply that with a drone now based on the heat map you were able to develop and collect with your multispectral sensor. So you can apply only the areas of the field that need the herbicide or that need the fertilizer, so you can actually lower that cost. It's actually also making a difference in forestry, in the forestry area. Before timber can be harvested, in some cases, especially where it's in a very mountainous region, they've got to be able to analyze that elevation and that terrain so they can move this heavy equipment in to be able to come in and harvest some of this timber. So having a LiDAR-based solution can allow you to really fully analyze and make sure that there aren't any unsafe landslides in the area that would prevent a crew from being able to safely come in and harvest that timber. So it is used in forestry applications as well. Construction, like we talked about earlier, being able to do those progress reports as the project is continuing on, and being able to do the volumes on those stockpiles. Again, I just kind of mentioned it earlier with photography, but real estate is definitely another avenue where drones are being commonly used to be able to showcase those properties. A few more are emergency disaster response, definitely following earthquakes and hurricanes and things like this. Being able to very early on go in and assess that damage for insurance purposes is very important. It's being used in the healthcare sector as well. It's also being used in mines and quarries to be able to, very similarly to stockpiles, instead it's calculating the amount of volume that's being taken out in mines and quarries. Also, progress reporting is very important for mines and quarries as well. Personal transport is kind of also a part of the future of drones and what they're going to be capable of doing. The ability to have a drone for you and your family is something that's actually actively being worked on, and it's going to enable a whole new method of transportation and mobility to societies all over the world. Telecommunications, and also I would put in with that power generation, being able to use LiDAR and other scanners and cameras to be able to inspect those power lines, to be able to classify those lines with LiDAR data. That's definitely something very important. Entertainment industry, you can oftentimes see, in lieu of fireworks display, sometimes now you see really nice drone displays for entertainment. Package delivery has been something that's been talked about for several years now. As the FAA continues to develop their rulemaking regarding beyond visual line of sight flights, that will enable the day where package delivery can occur safely and legally. And then, of course, the one we've been talking about all day today is surveying and mapping with drones. So that's definitely another industry that drones have a ability to really expand and really take it into the next stage of surveying and engineering evolution of data collection. So we're going to go ahead, and I want to start another little quick video here. I want to show you some really interesting drone swarming technology that is also coupled with artificial intelligence. This is something that DARPA has been working on drone swarms being launched out of the back of these F-16 fighter jets. So let's take a look at this quick video about some of the cool futuristic things that drones are working on.
Center line, entering containment area, clear arm. Okay, we're armed. Coastal 3-1, 2 pods armed. Coastal 3-2, 2 pods armed. 3-3, 1 pod armed. 5, 4, 3. Mark release. So 3-1, distance complete.
So there's a little bit more about some of the more advanced futuristic things that military applications with drones and artificial intelligence are making able for operators to do. And so next, I want to move on to one other slide here, and I want to talk about counter UAS. So we talked about drones in the sense of being able to collect data. But of course, as with any new technology, there always are bad actors that can use them for nefarious means. So in addition to the proliferation of these drones, you've also got all kind of new technology that's coming out to be able to counter these drones, to protect our airports, to protect sensitive military sites and convoys and things from a drone attack, which you're seeing and hearing more and more about these days. So what I want to show you here is a really neat video about one type of drone counter UAS technology that's coming today. So really the future of unmanned aircraft systems is very broad. There's so many different applications from a commercial sense, civil aviation, military applications. But really, the more advanced and the more prevalent UAS operations will become more and more commonplace as time goes on. I would imagine in 10 to 15 years, a majority of surveyors will be using a drone like this with LiDAR, with a camera-based system, or some sensor that we're not even thinking of right now as a part of their regular everyday workflow. You know, you could almost look at the time we're at now as the same scenario we were in the early 90s when GPS was first coming out. I'm sure many of you watching this video can remember back to those days and what your thought process was at the time. What is this GPS? I'm going to have to completely redo how I work. It probably was a very seemingly daunting task at the time. Whereas now, I would venture to guess that most of you that are watching this video are all using GPS, and it's part of your regular everyday workflow. I believe the same will be true for drones over the next 10 to 15 years. They will become so ubiquitous in not only the surveying and engineering realm, but across all spectrums of industries to overall improve the efficiency and just overall ability to do work in our every day-to-day lives, especially as automation becomes more prevalent and artificial intelligence starts to become more and more widely available. Like I just said, I believe UAS will become ubiquitous, especially as their use cases continue to expand. The tasks performed by the UAS equipment with artificial intelligence will allow the machine to make decisions based on the job it is assigned to. So if you can imagine, as we progress these next 10 to 15 years, the FAA is continually working towards allowing beyond visual line of sight flights. I could easily foresee the day where you have one of these drones at your office that's in an enclosed structure. And when you have a project to do, that project can be assigned to the drone. Flight times will be far greater than what they are today. The drone will leave your office, could fly as far as an hour away. We're in Baton Rouge now. I could even foresee if you have a project in Lafayette, the drone takes off from your office, flies over to Lafayette, collects the data on the project site, and then flies back to its home base to land and then start sending the data or uploading the data to your system. I could very easily see a scenario like that in the next 10 to 15 years. UAS will be used for functional purposes as well as entertainment in the future. And to conclude our presentation today, here's a little bit of a taste of things to come. So I want to thank all of you today for really taking the time to listen to this video. I really hope that many of you have come away with a greater understanding and insight into not only what drones are capable of doing now, what they will be able to do in the future, but most importantly, how your current projects and your applications can be outfitted or augmented with the use of a drone, whether that be with a LiDAR scanner or a photogrammetry setup. I really firmly believe that these drones will become more and more prevalent in really across a lot of industries, but especially in surveying and engineering. So I really want to thank you all for taking the time to listen to this presentation today. Again, my name is Ross Kenney. I work with Navigation Electronics. I'm the UAS sales and support lead for the company. And through LSPS, my contact information and our company's contact information will be provided to you if you have any questions about what was discussed here. So I want to thank you again very much for taking the time here today. I hope you learn a great deal from the other speakers here at LSPS and enjoy the rest of the convention. Thank you. Have a great day.